This lesson deals with supplemental problem 4.3. You can find this problem in the ECE302 ebook in the Chapter 4 Supplemental Problems on the bottom of page 2. Suppose you have an N-channel enhancement MOSFET. It has a threshold voltage of 2 volts and a value of K of 0.5 milliamps per volt squared. For what range of values of VDS does this device remain in the ohmic region if the gate source voltage is 5? And then repeat that for being in saturation. I've drawn the schematic symbol for an N-channel MOSFET where I've got the drain, source, and gate. Labeled the gate source voltage, the drain source voltage, and then the gate to drain voltage. To be an ohmic, the gate source needs to be greater than or equal to threshold, and the gate to drain needs to be greater than or equal to threshold. What's the gate to drain voltage? Let's just go around the loop here. The rise in voltage is the gate to drain, the drop is the gate source, and then minus the drain source. And that's this equation here. We're saying the gate source is equal to 5, and that the gate to drain needs to be greater than or equal to threshold, which is equal to 2. We can solve for the drain to source voltage. Put that on this side of the equation, so the drain source is now less than or equal to 5 minus 2, which is equal to 3. To be in saturation, the gate source needs to be greater than or equal to threshold, but now the gate to drain needs to be less than or equal to threshold. Same equation, the gate to drain is the gate source minus the drain source. Gate source is 5, but now we're going to be less than or equal to 2 volts. And solve for the drain source voltage, put that over here. That's going to now be greater than or equal to 5 minus 2, or 3. And this is supplemental problem 4.3.